Okay, so in this week, what you are going to do, you first of all, you will get the learning material for this week lab session under content and weekly topics and learning materials. Then week 7, then lab instructions are under lab folder and data set which you will be using this week is under data set. Okay, so as far as the lab is concerned, you can see here there are 3 files given. Okay, can you see this? Okay, so this is lab 7. So I will explain what is lab 7, what you need to understand. Then this is the case study, the program which you can download and open it in Google Colab. And this is for self assessment, I mean for self understanding, data pre-processing. Okay, so I will begin with lab 7. So I already have it in my system, so I will open it. So this is what you will see. So what I'm doing this week, so far the program you have implemented in the lab in week 3rd, you basically started implementing program in week number 3rd, then in week number 4th you completed one model, machine learning model program. Then week number 5 was the reading week, and in the last week you worked on a case study. Am I right? So far what you did, you worked on or you implemented the program, and in the program you implemented some machine learning algorithms, or in other words you can say you implemented some machine learning models. Okay, so when you implemented machine learning model, so what you did basically, you implemented supervised machine learning model. If you remember, when we discussed introduction to machine learning algorithms in week number 3rd in the lecture session or in the lab session, I explained that machine learning algorithms are basically classified in into three groups. Okay, the first group called as supervised machine learning algorithm, the second group called as unsupervised machine learning algorithm, and the third group called as reinforcement learning algorithms. Okay, this is what we discussed. Am I right? And how you will get to know, how you will come to know that for the given data set or the data set which you have, you should apply supervised, unsupervised, or reinforcement if the data set is labeled data, if the class label is given. Okay, like when you implemented your program for iris data set, iris data set consists of 4 feature vectors and 1 class label, type of flowers. Okay, when you implemented program for case study, income class classification, then the last column was for the income, less than 50k, more than 50k, or equal to, less than or equal to 50k, or higher than 50k. Am I right? If the data set which you have, if there is no class label, if there is no class label in the data set, then we will apply unsupervised learning algorithm. Is this point clear? Yeah, so if there is no class label in the data set, we will apply unsupervised machine learning algorithm. And clustering is one of the technique. Like in supervised, you implemented k nearest neighbor, you implemented decision tree, we discussed the support vector machine. Okay, different algorithms like random forest. So there are several algorithms you implemented. Am I right? Okay, so if you are going to apply clustering method, so how you will get to know that for this data set I should apply clustering method? What is the criteria? The criteria is dealing with unlabeled data. If the data set you have, if the data set provided to you has no class label, then in such situation you will apply clustering method. On the other hand, after checking the data set, if you feel that the data set has class label, then apply supervised learning technique. Is this point clear? So situation where you are going to apply clustering method is clear. If there is no class label, clustering method. If there is class label, supervised. Is this point clear? Clustering algorithms, there are different types of clustering methods which we will discuss in the class in detail, but here I will just quickly brief you what is clustering method and how to apply it. Is it okay? So you can see here clustering dealing with unlabeled data. Dealing with unlabeled data means if data set has no class label. Is this point clear? Are you sure? Yes. Unsupervised machine under unsupervised machine learning technique, we have clustering algorithm. Okay. So I will begin with what this is the attendance code. You can mark your attendance. Is it done? Can I start now? All right. So here you can see some brief, brief idea about what is clustering is given. So the first point, it clearly says it is unsupervised learning technique. I already mentioned clustering is unsupervised learning technique. And if you are going to apply unsupervised learning technique, you are going to apply supervised learning technique, you are going to apply reinforcement learning technique. What you have to have? You have to have data. So require data, but no label. Class label will not be there. It identify the pattern. So what it does, clustering means making a group. Okay, if you have 100 data points, okay, for example, suppose you are a teacher and you are teaching artificial intelligence to 100 students in your class. You have 100 students in your class, okay, and you have been asked to create a cluster, create a group of students who have scored marks 40 to 50 range. First range is 40 to 50, second range is 51 to 60, third group is 61 to 70, next group is 71 to 80, next group is 81 to 90, and next group is 91 to 100. So how many groups are there? 5 to 6 groups you are creating. So how many clusters you are creating? You are creating 6 clusters. So basically what will happen if there is a cluster, first cluster you are creating, let me draw it here. Suppose you are creating a clusters of, let's say, just for understanding, I am creating a 3 clusters. First cluster, second cluster, this is my second cluster, and this is my third cluster. Okay, so I created clusters, and I have how many data I have 100 data. 100 students means 100 data points, 100 instances. Okay, first student name in the first row, second student name will be in the second row, third student name will be in the third row. Is it clear? So let me consider a table like this. So this is student id, sid, and this one is marks. Okay, is it clear? We do not have let me add one more column in this. Insert, right? Okay, if pass, fail. Okay, if this type of information is there, so we will say that this is a class label. So but we do not have this. So let me, now this point is clear. Yeah, so now what I will do, I will delete this, delete this column. So the data set which we have, it has no class label. So here student id is, let's say, 102 is student id, and marks is 40. Second student id is 103, marks is 70. Next student id is, let's say, 104, and marks is, let's say, 80. Next id is 105, marks is, let's say, 85. Next id is 106, marks is 55. Is it clear? So like this, you have marks of 100 students. Okay, so you have marks of 100. Okay, or you can say 200, starting from, let's say we are starting from 1. This is 2 for better understanding. Okay, is it clear? So that it will be 100, so you will not get confused. And like this, you have this is for fifth student, and then you have 100 students. Okay, and marks is, let's say, 60. Is it clear? Is this point clear? So this is the data set, and this data set has no class label. And what you want to do, based on the marks, student marks, the student have scored some marks in the assessment, and based on the marks, you want to identify student has passed in the exam or in the assessment, or student has failed in the assessment, or you want to create a group like fail, good, very good, excellent, outstanding. Okay, these are the labels you want to assign, but this type of label is not given in the data set. Is this point clear? So yeah, you want to create a group. So what you are doing, you are creating a group of fail students. So fail means this, if this is a fail group, so what will happen if the failing criteria is marks is less than 50, student is failed, so how many student will go in this group? 40. Just one student will be in this group. Is it clear? Secondly, if this group is for good, and the criteria for good marks is, let's say, starting from 50 to 65, for example. Okay, starting from 50 to 65. So can you see, this is for good. So how many students will go in this group? This one will go. Okay, just 155, 55 and 60, two student. Is this point clear? 55 and 60. Is it clear? Now suppose this group is, let's say, a very good group. Okay, and the criteria is 66 to, let's say, 90. Okay, 91 to 100, excellent. Okay, so how many? 70 will go in this. 70, 80, 85. Is it okay? So 3 will go in this group. So what you did, you created 3 groups, and these 3 groups are called as 3 cluster in cluster algorithms. Is this point clear? So you have a data set. Data set has no label. Okay, and since the data set has no label and you are going to make a group, so what you will do, you will apply cluster method. The idea of cluster method is you are creating a group of similar type of data. Similar type of data means, suppose this student has scored let's say 35 marks. So this student and this student marks, I mean student ID 1 and student ID 2 are of same type. So same type means they both will fall in this category, and your algorithm, your model cluster algorithm, will predict fail. This is what you want to do. Is this point clear? Is this example clear? So this is what you want to do in case of cluster algorithm, clustering algorithm. Okay, is it clear? Yeah, so same thing is given, grouping the data, grouping the data point, similar of similar nature. Exactly. It is okay. Now read the point again. So clustering is unsupervised. Why it is unsupervised? Because it has no label. Now it requires data. Yes, you have to have data if you are going to create a cluster. Without the data, you cannot create a cluster. And the data will be without label, no label. Second point is clear. What you are doing, you are detecting a pattern. For example, in the example which I explained just now, in my example, what pattern I am creating? I am creating a pattern of fail, good, very good, excellent. Okay, so based on the data, you will identify this data will fall in fail category. This data marks will fall in good category. This data will fall in very good category, and another one will fall in excellent category. So you are creating a pattern. So like you are creating group of emails, group of marks in the example based on search result. Customer shopping pattern, like you are going to buy something and your company want to analyze the behavior or the nature of a customer based on their buying pattern. For example, Amazon. If I'm checking any product and I'm checking all the time, my interest is in mobile phone. So what I will do, what company will do, company will understand my behavior, and based on that they will recommend. I will start getting email, I will start getting advertisement on my social media account, or I will start getting messages on my mobile phone. Have you noticed this kind of thing? So they create a cluster of customers, and when they are shooting the email, they are shooting some advertisement, it will go to that group only. It will not, suppose you are searching for mobile phone, I am searching for, let's say, some food item, so I will not get email for mobile phone, I will get recommendations for food item. Is it okay? So it creates a region of images useful when don't know what you are looking for. You are unclear because class label is not there, so based on the data it is unclear. You can apply clustering method to infer some information from the data. Is this slide clear? Now, so same example is given here. So suppose this is one cluster, this is another cluster, this is another cluster. So what is the idea? The idea is creating group. Can you see the difference? So these two data cluster have similar type of, so we have three different types of data in this example. So this is first data, second data, third data, and this data has different group. But on the other hand, this one, like all marks are less than 50, all marks are less than 50. So rather than putting in a separate group, we can combine and we can put it in the same group. Is it okay? So here, if you are applying clustering method, the idea is very simple. Just like in k nearest neighbor, we determine the distance of the data point. What is the distance of this data point? This data point is far from this data point. Are you getting my point? So we cannot put this data point in this group, but these data points are very close. How to determine this? Based on distance. And if you remember, we discussed the formula for finding the distance: square root x2 minus x1 whole square plus y2 minus y1 whole square, when we discussed the traveling salesperson problem. Yeah, so this is the formula: x vector minus y vector. So x vector is feature vector 1, feature vector 2, square root. So this is a simple formula. No need to worry about, you have not to do this calculation manually. Okay, your program will take care of everything. You need to just call the function, and in order to call the function, you need to import the appropriate library in your Python program. Is it okay? So this is how you will your cluster algorithm works. And as far as cluster algorithms are concerned, cluster algorithms are basically divided into two groups: partitioning algorithm and hierarchical clustering algorithm. So as I said, if you remember right in the beginning, cluster algorithms are different types. Depending upon the data, you can select the correct or appropriate clustering method. So clustering algorithm broadly broadly classified into two groups. First group called as partitioning algorithm, and the second group called as hierarchical clustering. So in partitioning algorithm, there is k-mean clustering, mixture of Gaussian, spectral clustering. So three types of clustering which fall under flat clustering. On the other hand, hierarchical clustering, bottom up and top down. We will discuss all these things in detail in the lecture session. Okay, so what you need to do in the lab session, you just implement the program, and explanation is given. Read the explanation and try to understand your program. Is it okay? For reference, you can see this link for referencing. If you will open this, this is from scikit-learn. So you can see, like, there are different types of clustering techniques. You can see these are all our clustering techniques. Is it okay? So this is just for reference. Now, after this, the task. So for completing the task of this lab, what you need to do, you can download the Python programming file from week 7 lab. Okay, which program? Let me show you the program which you need to download. So here this is week 7. This is the program I'm talking about, case study clustering method. Okay, download this program. Have you downloaded? Yeah. Now open Google Colab. Open Google Colab. So here Google Colab is already there in my system, and then upload it. So my program is here, so I will upload it. Is it okay? Are you able to see your program? Yeah, just take your time. Have you opened Google Colab? All right. So here you can see the detailed explanation of each step is given. What you need to do, can you see this? So these are the different steps you need to follow for completing this program, and you need to understand each step one by one. Okay. So now the next step is, what is the next step? So you completed the first step. Now what is the next step? The next step is download the data set. So open Brightspace again and open dataset folder. Live dataset is there. Download this dataset. Okay. And then load the dataset in Colab. You already know how to load. Yeah. So just click on this file button and then right click here, upload. My dataset is here. So I will upload the dataset and then okay. So dataset is loaded now. All right. Yeah. So before when you will work here, I'm explaining, so you are following the step, but when you will start working without any support, here I'm supporting. Okay, when you are doing it, you need to first check the data set. Now check the data set. When you will click on the data set, you will be able to see the data set. Okay, so here you can see this is the data set and it has no class label. It has just feature vectors. Okay, is it okay? Yeah, so it is loading. So it will take some time. Anyway, you can minimize this, open download, home, open download, live here. So you can just open from here. Okay. So there will take some time. Okay. So here you can see it has no class label. Okay. It all are feature vectors. Okay. The information about the data set is given in the program. Is it okay now? So far things are clear. So this is the data set and this data set has no class label. Now let me. Sorry. No class label. What will be the class label? You need to. I'm coming on your question. So if you will see here, section 6, dataset description. So here, this is the link. I downloaded the dataset from here. Okay. So here you need to read this. Missing values, unit. So you need to read the information about the variables. So it has no class labels. You need to read here. Okay. You can read from here to know about dataset. Okay. That is the reason I have given the description. Okay. So what this dataset is, that this dataset is, we have used Facebook live seller in Thailand dataset. Download this dataset from UCI website. This is the website. Okay, the dataset consists of Facebook page of 10 Thai fashion and cosmetic retail seller. Okay, so they are collecting some information. Status type, behavior variable consists of post of different video, photo, status and link. Now see, you have status ID here or not in this dataset. So you can see status type. It consists of video, photo. Can you see it here? Yeah. And this is the variable we are discussing here. Okay, status type behavior variable consists of post of different photo, video, status, and links. It also contains engagement matrix of comments, share, and reactions. Okay, but it has no class label. This type of information is not there. Okay, all are just input. Now it's clear. Yeah, so for doing for playing around the data set, what you need to do, you need to first load the library. Okay, you need to first load the library. Can you see this point? Importing the libraries, you know about this? Yeah, then this is the data set I'm loading. So let me run my program one by one. So initially some explanation is given. Okay, so you need to read the explanation. What is k-mean clustering? What is centroid? What is centroid? Centroid means finding the center of the cluster. Suppose this is your cluster. This is the cluster. Okay, this is the cluster. So this cluster has a center point. Am I right? That is, the center is here. For example, this is the center. Okay, let me fill a color in this so that we can see the difference. So this is the centroid, center. Okay, so what you will do, what algorithm will do, algorithm will find the distance of the data point. Suppose this symbol represents a data point. So this is my data point. This is my data point. So what you will do, what algorithm, you mean what algorithm will do? Algorithm will find the distance of this data point from the centroid. Okay, so this is the centroid I'm talking about. So based on the distance, if data set is here, so it will fall in this group. On the other hand, if you have another data set which is here, okay, and there is one more cluster and the cluster is somewhere here. Okay, try to understand. You have two cluster. This is first cluster, this is second cluster. You have two data point. One is this data point. This is the data point. This is the data point. Sorry. This one is the data point. Let me fill some color so that you can understand the data point. Is it okay now? And there is one more data point like this. So what is the aim? The aim is to and you are creating clusters like this and like this. Okay, the center for this cluster is somewhere here. This is center for this cluster and this is center for this cluster. Okay, so what your algorithm will do, algorithm will evaluate the distance from the centroid of this cluster. What is the distance from this point to this point and distance from this point to this point for cluster 1? Is it okay? And similarly, your algorithm will determine the distance from this cluster to the distance of this data point and distance of the other data point. All right, is it okay now? So when you are evaluating the distance, what is the finding? The finding will be very simple. The distance of this data point from this center will be less. Okay, and the distance from for this data point to this cluster will be more. Whereas the distance, is this point clear? So far what I explained is clear. Whereas the distance of this data point will be more from this cluster, centroid point. Is it okay? And the distance of this cluster, this data point will be close to this cluster. So the idea is, if the distance is close to any cluster, place the data point in that cluster. Is it okay? Is this point clear? So this data will go in this cluster and this data will go in this cluster. Is it okay? And then you can say that this is one group and this is another group. Does it make sense? Same thing is explained here. Now see, a centroid is a data point at the center of a cluster. Is it okay? Same thing I explained. In centroid based clustering, clusters are presented by a centroid. So centroid will be the key of placing the data point in any cluster. And how to place the data? Data will be placed based on this formula, the formula I explained here. This is the formula, finding the distance of data point from the centroid. Is this point clear? So you need to read and understand. I will explain all these steps one by one. So finding the centroid, then data assignment step, then centroid update. Each time after placing one data, you need to update. You need to repeat the same step for new data. Repeat the same step for a new data point. Repeat the same step for another data point until there is a data point present in the space. Is it okay? Yeah. And choosing a value of k, so based on k you can choose this elbow method. Elbow, you know, elbow. Okay, so how to select the value of k we will discuss. So we will discuss, like, if we will start from the top and we will reduce the distance and then we will select. So read about this. Then what is the problem statement, and then data set. So this is the problem statement. Okay, I implement k-mean clustering with Python and scikit-learn. As mentioned earlier, k-mean clustering is used to find intrinsic group. So you are creating a group. Is it okay? And for the data set, we are selecting this data set. The data set link is the dataset link is presented here. You can download the dataset from here. I already provided the dataset in Brightspace. This is the dataset I loaded, and then I will start writing my program. So initially, the first step is loading the library. So let me load the library and try to run this program. It is working fine. Then for ignoring the warning, I am implementing this part. Then dataset, when you are running this, you need to make sure your dataset is in the environment or not. All right. Then run this and read the data set. So running your program and reading the data set. Is it okay? Is this point clear? So now your data set is in df. If you will display df, if you'll just write df here, if you will just write df here, you will be able to see the data set. See, now the same data set is here. You have to run the library first now. Okay. So you can see the data set here. Okay, and it has none. Okay, so you are intentionally I added this. Okay, because I provided a program, data processing program. I have already provided. Okay, so I intentionally added 3-4 columns in it. 3 columns just for you to deal with it. 4 column, 5 column doesn't matter. Okay, it's clear now. So this is, and then shape, you know how many columns has, I mean how many instances, how many feature vectors. Shape you already know, you already implemented shape. Okay, so it has 7050 instances, rows, and how many columns? 16 columns. Okay, where 3-4 columns are empty. Yeah, you can see it here. Yeah, so 3-4 columns, like column 1, 2, 3, and 4. Columns are the data feature vector. So it has feature vector. So this is a feature vector. This is instance, row, instance, column, features. Is it okay now? So is this point clear? Yeah. And then head to display first 5 instances randomly. Yeah. Is it okay? 5 instances. If you want to display first 10 instances, what you will do? You will simply pass 10 as an argument to this, and then when I will run this, what it does, it will display first 10 instances. Does it make sense? Yeah. If you want to, so by default it displays 5 instances. Okay, if you want to see specific number of instances, then you can run, you can pass some values like 10, 20, 50. Okay, if you want to see, let's say you want to see last 10, so what will happen? Last 10. So for checking last 10, tail and then 10. df dot tail 10. I think you already did all these things. And then this is for info. So just run, and then for checking the null values. So you can see for here, can you see this, checking the null value? So there is no null value present in the feature vector, but null values are present in column 1, 2, 3 and 4 because it has no values. So null values are there. Is it okay? Then since we are not since data is not present in column 1, 2 and 3 and 4, so what you can do, you can drop, because column 1, 2, 3 and 4 has no meaning. It has no role in the implementation, in the analysis. So you can just drop. So this is how you can drop. Okay, because I have given a challenge after explaining this. So what I want you to do, I want you to just process this and understand the program. Is it okay? Can you do this? You can try. Okay, then here you can see clustering is given. So for clustering, you need to import this library from k-mean clustering, then apply some method, and then that's it. Is it okay? I will explain about clustering technique in detail. Now I was talking about the challenge. Now let me open the slide. So this is the task. I already explained the task. You can get the program from the Brightspace. You can get the data set from the Brightspace. Open program in Colab, load the data set, then run the program and develop your understanding for by each step by step. Is it okay? Is it clear? Just understand the steps because you are implementing cluster method for the first time. Okay, now I was talking about the, is this point slide clear? All the steps are clear now? Okay, now the next step, which is very, very important, once you are clear, your program is working, you have understood all the steps given, all the instructions given in the program, then the task is now you have to implement the program yourself. Okay, this is the program I am providing. Okay, and you are understanding. Now you, when you feel that your program, you have understood this program very well and you can play with the instruction, the program, the challenge is given here. You have iris dataset, am I right? You can get the iris dataset or you can directly download the iris dataset. Implement the same program for iris dataset. You need to think how you are going to implement it. How you will implement, because this data set has label. Is it okay? Iris data set has label. So that is the reason I have given challenge. So I'm challenging you, once the program is clear to you, implement the same program for iris data set. Now you need to think how to implement it. If not, if you will not be able to implement, I will give you some tips and tricks in the next lab. Is it okay? So first step is understand the program and then use your understanding and implement the clustering algorithm for iris dataset. Use a new iris dataset. You implemented before, but for previously when you implemented your program for iris dataset, you use supervised learning technique because supervised learning technique have label and iris dataset consists of class label. So that is the reason you implemented, you selected supervised learning technique. The challenge which I'm giving to you is use iris dataset. It has class label and then apply unsupervised clustering technique, k-mean clustering technique. Is it okay? So this is the task for this lab. So, but I'm telling you, no need to apply supervised. So you need to decide. Okay, you need to decide how to do iris dataset. Yeah, it's clear now. Yeah, so this is what you need to do. All right, any question, any clarification you need? Case study, how about you? Have you worked on case study, last week case study? Yeah. Have you started working on report preparation? I think you came late. So, sorry? I already uploaded the video. So you can, have you marked your attendance? Attendance. Please mark your attendance. Is everything clear for this week? So, yeah. I know. You cannot say for others. Yeah. Is it attendance done? Attendance done? No, not yet. Yeah. So what I did, I recorded this session, whatever we discussed.